Hello everyone, I'm Saeed Al Samahi from grade 11 ESP, and today I'm going to solve some questions, some AP questions about limits and continuity. So let's start. So here, let f be the function defined by, as we can see here, the piecewise function. So the question says, is f continuous at x equal to 3? Explain why or why not. So if it is continuous, f of 3 must equal the limit as x approaches 3. So let's check f of 3, which equals to, here we can see it is 3, so square root of x plus 1, which is square root of 4, which is 2. So now we check the limit from the both sides. So limit as x goes to 3 from the negative side, square root of x plus 1, which is equal to square root of 4, as we found before, which is equal to 2. Now we check from the left side. Limit as x approaches 3 positive, f minus x, because here it is greater than 3, which is equal to f5 minus 3, which is equal to 2. So since f of 3 equal to limit as x approaches 3, f is continuous. F is continuous at x equal 3. So we go to the next question, which says a 12,000 liter tank of water is filled to capacity at time t equal to 0. Water begins to drain at the tank at rate modeled by r of t. Here is r of t, the piecewise function, measured in liters per hour, where r is given by the piecewise defined function below. The question says, is r continuous at t equal to 5? Show your work that leads to the answer. So, as we said before, if it is continuous, r of 5 must limit as x approaches 5. So first we take r of 5, which is here it approaches 5, so 600 by 5 over t plus 3, which is equal to 3000 over 8, which is equal to, hold on a second, 3000 over, which is equal to 375. Now we check the limit. Limit as x goes to 5, we should check on both sides. So from the minus side, from the left side, as we can see here, it is smaller than. So 600 t over t plus 3. Here we should put t, t plus 3, as we got before, 3000 over 8, which is equal to 375. Now we check the limit from the right side. As t approaches 5 from the right side, 1000 e to the power 0.2 t, so which is equal to 1000 e to the power 1, which is equal to, hold on a second, 1000 times e which is equal to 2718.28. We can conclude that r isn't continuous at t equal to 5, since the limit does not exist. So we move to the next question. Since r isn't continuous at t equal to 5, since limit does not exist. So we go to the next question, which is also about continuity, which says let f be a function defined by f of x, as we can see here, the piecewise, show that f is continuous at x equal to 0. So as we said, f of 0 must be equal to limit as x approaches 0. So first we check f of 0. Here 0 is approached in 1 minus 2 sine 0, which is 1 minus 0, which equals 1. So now we check the limit as x approaches 0 from the left side, as we can tell here. We take the function 1 minus 2 sine x, which is equal to 1 minus 0. Sine 0 is 0, so 1 minus 0, 1. Now we take the limit from the right side. Limit x goes to 0 on the right side, e to the power minus 4x, which is equal to e to the power 0, which is equal to 1. So f is continuous at x equal to 0, since f of 0 equals limit as x approaches 0. So here we came to the first multiple choice question, which says for which of the following does limit x goes to 4 exist? So here, first graph, x from both sides approaches 3, so this one exists, and the same here, from both sides it approaches 4, so it exists. Here we can see discontinuity, jump discontinuity, so it doesn't exist. So we have I and II, so we have the choice D. Now we go to the, which question? First, second, third, fourth. We go to the fifth question, which says let f be the function given above. Here is the function. Which of the following statements are true about f? Limit as x goes to 3, f of x exists, so we should check from both sides. Limit as x goes to 3 from the left side, from here it is 3 plus 2, which equals 5, and limit from the right side, which is equal to 4x minus 7, which is equal to 12, minus 7, which is equal to 5. So the limit exists. F is continuous at x equal to 3. So we should find out whether the limit equals f of 3. So we check f of 3 is equal to, as we can see here, it approaches 3. So 3 plus 2 equal to 5. Since the limit equals to the f of 3, then it is continuous. F is differentiable at x equal to 3. So we take the right and the left derivative. So we check f prime from the left of 3, which is from the left side, which is the derivative of x plus 2 prime, which is equal to 1. The constant get cancelled and x to the power 1 becomes 1, and f prime from the right side of 3, here is from the right side, which is equal to 4x minus 7 prime. The constant gets away, and 4 to the power 1 power times by 4, so it is equal to 4. It is not differentiable at x equal to 3, since the left and right derivative doesn't equal. So the answer is D. Now we go to question number 6 and 7. First, let's start with 6, which says limit as x goes to infinity x this rational numbers. So this rational numbers, I'm sorry. So we have rules. Since the highest degree here and the highest degree here are equal, x to the power 3 over 4x power 3, we make division between them. So 1, we are left with 1 over 4. So the answer is C. Now we go to question number 7. The graph of the function f is shown above. At which value of x is f continuous but not differentiable? At b, it is not continuous. At d, it is not continuous. So b and d are removed. So we are left at A, and C, and E. Here there is no a cusp or a turn, a cusp or a sharp turn. So E, it is differentiable. C the same. But at A, as we can see, there is a sharp turn. So it is not differentiable. So the answer is A. We go to question number 8, which says the figure above shows the graph of a function f with domain 0 to x to 4. Which of the following statements are true? Limit as x goes to 2 from the negative side exists. From the negative side, as we can see, it exists. True. Limit as x approaches 2 from the right side exists. As we can tell, it exists. Limit at f of x, limit of x goes to 2, f of x exists. We can, it doesn't exist, since the left and the right limit are not equal, so the answer is wrong. So we are left with C, 1 and 2. Now we go to the 9th question, which says limit as x goes to 0, f of x to the power 4 plus 8x squared over 3x power 4 minus 16x squared is. So if we substitute 0, the denominator would be 0, so it will be undefined. So we should factor it. Here, limit as x goes to 0, we take common factor x squared, 5x squared plus 8, and here also the common factor is x squared, 3x squared minus 16. So x squared gets cancelled, equal to limit as x approaches 0, 5x squared plus 8, wait a minute, 5x squared plus 8 over 3x squared minus 16. Now we substitute 0. Here we get 8 over minus 16, which is equal to minus half. So the answer would be A. Now we go to the last question, and question number 10, which says the graph of the function f is shown above in the figure above. Is shown in the figure above, as we can see here. Which of the following statements about f is true? So we look at the first statement. Limit as x goes to a, f of x is equal to limit as x goes to b, f of x. Here the limit is equal to 2, and here the limit does not exist, since there is a jump. So the first one is wrong. Limit as x goes to a f of x equal to 2. As we can see from both sides it equals 2, so the answer is correct. Limit as x goes to b equal to 2. It's wrong, as we said. The limit does not exist since the left and the right limit aren't equal. The same goes for D. Limit of x goes to a f of x doesn't exist. It is false because it exists. The left and right derivative goes to 2, but limit as x goes to b f of x doesn't exist. So the answer we are left with is B. And here is me solving 10 questions of 10 AP questions. I hope that you learned something from me, and have a nice day, everyone.